Welcome to chemistry classes. In this video, we are going to discuss about group 16 elements, P block elements part 4, group 16 elements. Okay. So here we know in periodic table group 16 elements are oxygen, sulfur, selenium, tellurium, polonium. These are group 16 elements. Oxygen, sulfur, selenium, tellurium, polonium. These are group 16 elements. Okay. Here we have to understand here occurrence of these elements. We know the most abundant element in the earth, oxygen. Oxygen is the most abundant element in the earth. Okay. Here in dry air, the percentage of oxygen is 20.946. 20.946 percentage. This is the percentage of oxygen in dry air. Okay. And the amount of sulfur in the earth, it is very less. 0.03 to 0.1 percentage. This is the percentage of sulfur in the earth. Here we have to understand here sulfur exists in two forms. Sulfur exists in two forms in the earth. Sulfur exists in the form of sulfate. Also it exists in the form of sulfide. Sulfur exists in the form of sulfate. Example, magnesium sulfate, calcium sulfate. Look here, calcium sulfate, CaSO4 2H2O, that is gypsum. CaSO4 2H2O, that is gypsum. MgSO4 7H2O, magnesium sulfate with 7 water molecule, that is Epsom salt. So these are the different form of sulfate. Also sulfur exists in the form of sulfide. Example, lead sulfide. Lead sulfide, this is the ore of sulfur. This is the ore of lead sulfide. Okay, this lead sulfide called galena, lead sulfide. And another one, zinc blende, this is the ore of zinc. Okay, sulfur exists in the form of sulfide. Example, here lead sulfide, and another one, zinc sulfide. Zinc sulfide also called zinc blende, this is the ore of zinc. Lead sulfide also called galena, this is the ore of lead. Clear? Okay, next one, we have to understand here electronic configuration of group 16 elements. Electronic configuration of group 16 elements, NS2NP4, that is electronic configuration. Atomic and ionic radius increases from top to down. Next point, atomic and ionic radius. From oxygen to polonium, we know size of the atom increases, atomic number increases, size of the atom increases. That's why atomic radius and ionic radius increases from top to down. Similarly, ionization enthalpy. Ionization enthalpy decreases from top to down because size of the atom increasing, distance between nucleus and outer shell electron increases, distance increases. So less attraction between nucleus and outer shell electron. So we can remove outer shell electron easily. So ionization enthalpy decreases. Ionization enthalpy decreases from top to down. But compared to group 15 elements, compared to group 5 elements, group 6 elements shows less ionization enthalpy. We discussed before nitrogen, phosphorus, arsenic, antimony, bismuth. Okay, compared to these elements, oxygen, sulfur, selenium, tellurium, polonium, this element shows less ionization enthalpy. This is group 15 elements, this is group 16 elements. Group 15 elements, they have half-filled configuration, their outer shell electronic configuration, half-filled configuration. Half-filled configuration, it is more stable and it needs more energy to remove outer shell electron. But compared to group 15 elements, group 16 16 elements, they have less energy to require outer shell electron, less energy needed to remove outer shell electron. Okay, so ionization energy of group 16 elements are less than group 15 elements. Clear? Next one we have to understand here, electron gain enthalpy. Electron gain enthalpy, electron gain enthalpy decreases from top to down. Electron gain enthalpy decreases from sulfur to polonium. Look here, electron gain enthalpy decreasing from sulfur to polonium. But there is one exception case. Electron gain enthalpy of oxygen is less than sulfur. Remember this, electron gain enthalpy of sulfur is higher than oxygen. Okay, here electron gain enthalpy increasing from oxygen to sulfur, but after sulfur, from sulfur to polonium, electron gain enthalpy decreasing. Okay, so here generally you can say electron gain enthalpy decreasing from top to down, from sulfur to polonium, but electron gain enthalpy of oxygen is less than sulfur. Sulfur has higher electron gain enthalpy. Okay. Next one we have to understand here, electronegativity. Electronegativity here decreases from top to down. Electronegativity decreasing from top to down. Okay. Here highest electronegativity, fluorine. Fluorine shows highest electronegativity in periodic table. After fluorine, oxygen is the second most highest electronegativity. Okay, oxygen shows next to fluorine, oxygen has highest electronegativity. After fluorine, oxygen has highest electronegativity. Okay, so here we discuss electronic configuration of group 16 elements NS2 NP4. Atomic and ionic radius generally increases from top to down. Similarly, ionization enthalpy decreases from top to down. But compared to group 15 elements, group 16 elements have less ionization enthalpy. Electron gain enthalpy generally decreasing electron gain enthalpy, but there is one exception case. Oxygen has less ionization enthalpy than sulfur, but generally electron gain enthalpy decreasing. Okay, similarly electronegativity of fluorine has highest electronegativity. After fluorine, oxygen has the highest electronegativity. Okay, electronegativity also decreases from top to down in group 16 elements. It means metallic character increases. Metallic character increases from top to down. Here oxygen and sulfur, it is non-metal. Selenium and tellurium, it is metalloid. Polonium, it is metal. It means metallic character increases from top to down. Clear? Okay, next one we have to understand here physical properties of group 16 elements. Physical properties. We discussed metallic character increases from top to down. Metallic character increases. Here oxygen and sulfur non-metal, selenium and tellurium, they are metalloids. Polonium, it is metal. Metallic character increases. Metallic character increases from top to down. That's why metallic character increases. So we can say melting and boiling point increases from top to down. Melting and boiling point increases. Okay. Similarly here you can see there is large difference in melting and boiling point of oxygen and sulfur. Compared to oxygen and sulfur, sulfur shows higher melting and boiling point. In periodic table, in group 16 elements, sulfur, you can see sulfur after oxygen. Sulfur is after oxygen, but sulfur has higher melting and boiling point compared to oxygen because of their atomicity. because of their atomicity. Here oxygen it is diatomic, and here sulfur it is polyatomic. Okay, one molecule of sulfur which consists of 8 atoms. Okay, so here sulfur it is polyatomic and oxygen it is diatomic. Because of their atomicity, here there is large difference in their melting and boiling point in the case of oxygen and sulfur. Okay, so these are the things we have to understand about physical properties of group 16 elements. Next one we have to understand here chemical properties. Chemical properties of group 16 elements. Chemical properties, first one we have to understand here oxidation state. Oxidation state and trend in their reactivity. Trend in their chemical reaction. Okay, so oxidation state. Here the stability of oxidation state, stability of -2 oxidation state decreases from oxygen to polonium. Group 16 elements, they shows different oxidation state, -2, +2, +4, +6 oxidation state. These are the different oxidation state exhibited by group 16 elements. -2, +2, +4, +6 oxidation state. Okay, the stability of -2 oxidation state decreases from oxygen to polonium because metallic character increasing from top to down, so their negative oxidation state decreases. Okay, oxygen shows only -2 oxidation state. Oxygen shows only -2 oxidation state except one compound. Here oxygen difluoride. In oxygen difluoride, here oxygen shows +2 oxidation state. In all other case, oxygen shows -2 oxidation state. Here we know fluorine has higher electronegativity than oxygen. That's why here oxygen shows +2 oxidation state. Okay. Here we have to understand other point. Here except other all other elements shows +2, +4, +6 oxidation state. Except oxygen, other elements here sulfur, selenium, tellurium, polonium, this element shows +2, +4, +6 oxidation state. Okay, and here +2, +4 oxidation state, stability of +2, +4 oxidation state decreases from top to down. From top to down, the stability of +2, +4 oxidation state decreases. Also we have to understand here +4, +6 oxidation state, compound with the +4, +6 oxidation state, they shows covalent in character. They are covalent in nature. So these are the different points we have to understand here. Chemical properties of group 16 elements. Okay, group 16 elements shows -2, +2, +4, +6 oxidation state. Stability of -2 oxidation state. Also stability of +2, +4 oxidation state decreases from top to down. Oxygen shows only -2 oxidation state except in the compound OF2. Here oxygen +2 oxidation state. Okay, and here oxidation state with the compound with the oxidation state +4 and +6, they are covalent in nature. Clear? The next one we have to understand here anomalous properties of group 16 elements. Anomalous properties mean first element of the group 16 shows different properties compared to other group members. This is anomalous properties. Okay, oxygen shows high electronegativity compared to other group members. Oxygen shows high electronegativity, also very small size. Oxygen has very small size compared to other group members. Also it has high electronegativity. We can mention their electronegativity compared to melting and boiling point of H2O and H2S. Water has higher melting and boiling point. We know water, it is liquid state, boiling point 100 degrees Celsius. Similarly here H2S, it is gaseous state, low melting and boiling point. Okay, so here oxygen has high electronegativity. Oxygen has high electronegativity and oxygen make hydrogen bond. Oxygen make hydrogen bond. Here oxygen has high electronegativity. Oxygen is highly electronegative. Okay, and here hydrogen, it is electropositive and they make hydrogen bond. This type of hydrogen bond not possible in H2S because sulfur less electronegative than oxygen. Okay. So here we are discussing here anomalous properties of oxygen. Oxygen, it has high electronegativity compared to other group members. Similarly here oxygen has very small size. Clear? Next one we have to understand here reactivity of group 16 elements with hydrogen. Reactivity of group 16 elements with hydrogen. Group 16 elements react with hydrogen forms hydride in the form of H2E. They form hydride, the type of hydride form H2E. Here E represent group 16 elements. Example for this type of hydride H2O. Similarly here H2O, H2S, H2SE. Okay, so generally we can represent this H2E. Clear? This is the hydride formed. And we have to understand here acidic character. Here except water, rest of the hydride shows acidic character, and this acidic character, acidity of this hydride increases from oxygen to polonium. Acidic character of hydride of group 16 elements increases from top to down. Acidity increases. Okay. This is because here bond between hydrogen and group 16 elements. Bond between hydrogen and group 16 elements. This bond strength decreases from top to down. We know when we move from top to down, size of the atom increases. Size of the atom increasing from top to down. So bond between hydrogen and element. Bond between hydrogen and group 16 element. Bond length increases, so bond strength decreases. Bond strength decreases and it will lose H plus ion very easily. So acidic character increases from oxygen to polonium. Acidic character increases. Similarly here we have to say thermal stability decreases. Same reason here, the thermal stability of group 16 hydride decreases from oxygen to polonium because size of the atom increases. Size of the atom increases, so bond strength decreases. Bond strength decreases, so thermal stability decreases from top to down. Clear? And here we have to understand another point. Here this group 16 hydride, they shows reducing power. They have reducing power, and this reducing power reducing property increases from top to down in group 16. Okay, so these are the different points we discuss in reactivity with hydrogen. Group 16 elements react with hydrogen, form hydride, the type of hydride H2E. Example H2O, H2S. Okay. Acidic character of group 16 hydride increases from top to down because from top to down size of the atom increases, bond strength decreases, it can lose H plus ion easily, so acidic character increases. Clear? Here similarly another point, thermal stability. Thermal stability decreases. Thermal stability decreases from top to down because bond strength decreases. Bond strength decreases. Reducing power. Except water, all other group 16 hydride shows reducing property. And this reducing property increases from top to down. Except water, all other group 16 hydride shows reducing power, reducing property, and this reducing power will be increases from top to down. Clear? So these are the different points we have to understand about reactivity with hydrogen. Okay, next one we have to understand here reactivity towards oxygen. Group 16 elements reacted with oxygen form different type of oxide. Oxide in the form of EO2 and EO3. These are the two different form of oxide formed. Here EO2 and EO3. E mean group 16 elements, sulfur, selenium, tellurium and polonium. Okay, so these are the two form of oxide. Here we have to understand different form of oxide. Here O3 and sulfur dioxide. O3 mean ozone. Ozone and sulfur dioxide, these are oxide, they are gaseous state. They are gaseous state. Similarly here selenium dioxide, SeO2, selenium dioxide, it is solid state. So here different oxides of group 16, they have different physical state. Example here O3. O3 it is gaseous state, sulfur dioxide it is gaseous state, but selenium dioxide it is solid state. Here we learnt group 16 hydride, they have reducing power. They have reducing power. Okay. Similarly here, reducing property of group 16 elements decreases down the group. We learned group 16 hydride, their reducing power increases from top to down, but here group 16 oxide, their reducing power decreases down the group. Okay, look here. We learned hydride and oxide, group 16 hydride, their reducing power increases down the group. But here group 16 oxide, their reducing power decreases down the group. Clear? After that here we have to understand here, look here, sulfur dioxide. I told you here reducing power decreases down the group. So from sulfur dioxide to selenium dioxide, sulfur dioxide to selenium dioxide, their reducing power decreases. Okay, here you can say sulfur dioxide it is good reducing agent, but selenium dioxide it is not reducing agent, it is oxidizing agent. Clear? And here another point we have to understand. I told you here oxides of group 16 elements EO2 and EO3 type. So this is another type of oxide, EO3 type. Here E represent group 16 element, sulfur, selenium, tellurium. Okay, here not polonium, here sulfur, selenium, tellurium. These are the elements which coming here EO3 type. Okay, so here we discuss reactivity towards oxygen. Reactivity towards oxygen, here we have to understand all these elements forms oxide, and this oxide to form EO2 and EO3, and their reducing power decreases down the group. And here we have to understand sulfur dioxide it is good reducing agent, but selenium oxide it is oxidizing agent. Okay, so these are the different points we have to remember here. Okay, next one we have to understand here reactivity towards halogens. Reactivity towards halogen. Group 16 elements reacted with halogens. They form different type of halide. Halide in the form of Ex2, Ex4, Ex6. These are the different type of halide formed. Okay. So look here. Group 16 elements reacted with halogen. They form Ex2, Ex4, Ex6. Okay. And here group 16 halide, the stability of halide decreases from top to down. Group 16 halide, halogens with fluorine, it is highly stable. Okay, and stability decreases from fluorine to iodine. Okay, stability of group 16 halide decreases from fluoride to halide. Clear? Because fluorine, chlorine, bromine, iodine, from top to down, size of the atom increases. Size of these atoms increases. So bond length increases, bond strength decreases. So their stability decreases according to this order. Okay, and here another point we have to understand about Ex6. Ex6 mean group 16 halide, in this form of halide, Ex6. Here we have to understand only hexafluoride is highly stable. Only hexafluoride is stable. Rest of the hexahalo compounds are not stable. Okay, I told you here group 16 elements reacted with halogens. They form different type of halide. First one, Ex type. Out of Ex type, only hexafluoride compounds are stable, rest of them not stable. And hexafluoro compounds or Ex6 compound, they have octahedral geometry. Their structure is octahedral. Okay, and they are gaseous state. These compounds are gaseous state and they have octahedral structure, and their hybridization, here hybridization of group 16 element is sp3d2. sp3d2. For example, SF6, here hybridization of sulfur, it is sp3d2, and they are octahedral and they are gaseous state. Clear? Next one we have to understand about Ex4. Ex4. Here Ex4, example SF4, SEF4, TEF4. These are example for this type of halide. And here SF4, they are gaseous state. Okay, sulfur hexafluoride, they are gaseous state. And here selenium fluoride, it is liquid state. Tellurium fluoride, it is solid state. So on the top it is gaseous state. Halides of first element SF4. Okay, SF4, it is gaseous state. Selenium fluoride, it is liquid state. Tellurium fluoride, it is solid state. So hardness of this compounds, hardness of this halide increases from top to down. Clear? And another one we have to understand Ex4, they are sp3 hybridized. Their hybridization is sp3d hybridization, and they are trigonal bipyramidal. Their structure of this molecule, trigonal bipyramidal. Trigonal bipyramidal, also we can say seesaw geometry. Or trigonal bipyramidal, and they are sp3d hybridization. SF6, it is sp3d2, SF4, it is sp3d hybridization. Okay, and here sulfur fluoride, it is gaseous compound, and selenium fluoride liquid compound, tellurium fluoride, it is solid state. Clear? Another one we have to understand here, compound in the form of Ex2. The third form of compound Ex2. Okay, we discuss here sp3d2, sp3d, and this is sp3 hybridization. sp3 hybridization, and they are tetrahedral structure. These compounds are sp3 hybridization, tetrahedral structure. Okay, another point we have to understand here, all the group 16 elements form this type of halide except selenium. Selenium do not form Ex2 type halide. SeF2 not possible, not existing. Okay, rest of all group 16 elements forming Ex2 type halide. Ex2, it is sp3 and they are tetrahedral in geometry. Clear? So these are the different points we have to understand here. Okay, also understand here one more thing. We discussed selenium. It do not exist in the form of SeCl2. It do not exist in this form, but it will exist in dimeric form. Dimer, we know monomer and dimer. So it will exist in the dimeric form. Okay, for example, SeCl2. This is dimeric form. On heating, it will decompose. Decomposition of dimeric form of selenium chloride will happen, and this is example for disproportionation reaction. Disproportionation reaction means chemical reaction, both oxidation and reduction takes place. Okay, so here we discuss reactivity towards halogens. Group 16 elements reacted with the halogen. It formed different type of halide in the form of Ex2, Ex4 and Ex6, and the stability of this halide decreases from top to down. Okay, group 16 halide with fluorine or fluoride, it is highly stable. Okay, group 16 halide with iodine, it is least stable. Okay, and here we discussed about Ex type, Ex6 type compound. They are octahedral, sp3d2 hybridization, and here only hexafluoride compounds are highly stable. Rest of the compounds are not stable. Next one we discuss about compound Ex4. They are sp3d hybridization and they are trigonal bipyramidal or seesaw geometry. Okay, and here SF4 gaseous state, selenium fluoride liquid state, tellurium fluoride, they are solid state. Mean hardness of the compounds increases from top to down. Okay, in the case of Ex4. And the next one we discuss about Ex2 type compound. Ex2 type compound, all the group 16 elements except selenium, they form Ex2 type halide. Okay, and here they have sp3 hybridization and they are tetrahedral in geometry. Here selenium, it do not exist in the form of SeCl2, but they exist in dimeric form. Dimer. Okay, this dimeric form of selenium chloride, on strong heating it will decompose and it form SeCl4 and SeCl2. It is not stable. It will change to another form immediately. Okay, and here this is disproportionation reaction. Example for disproportionation reaction. Clear? Okay, next one we have to understand here dioxygen, O2. First one we have to understand here preparation of oxygen. Okay, preparation of oxygen we have to understand laboratory method of preparation and industrial preparation, large scale production. First one we have to understand here laboratory method of preparation of dioxygen. Potassium chlorate, KClO3, potassium chlorate, on strong heating it forms potassium chloride and dioxygen. Dioxygen means O2, oxygen. Normally we will say oxygen. Okay, so potassium chlorate means KClO3 on strong heating in presence of manganese dioxide. Manganese dioxide act as a catalyst over here. Okay, so potassium chlorate on decompose, it produce oxygen and potassium chloride. This is one method of preparation of dioxygen. Second method, Thermal decomposition of metal oxide. Thermal decomposition of metal oxide. Metals such as low in reactivity series. We know reactivity series. Arrangement of metals according to their reactivity. So metals which coming low in reactivity series and their metal oxide on strong heating, it will decompose and produce dioxygen. For example, silver oxide on strong heating, it produce silver and oxygen. Mercury oxide on strong heating, it form mercury and oxygen. Okay, another method of preparation of dioxygen, decomposition of hydrogen peroxide. Decomposition of hydrogen peroxide. Hydrogen peroxide means H2O2. 2H2O2 on strong heating, it forms 2H2O and oxygen. 2H2O2 on strong heating, it produces 2H2O and oxygen. In this case also manganese dioxide act as a catalyst. So these are the different methods. To prepare dioxygen in laboratory. Clear? Next one, we have to understand here large scale production of dioxygen. Electrolysis of water H2O. After electrolysis, it produces hydrogen and oxygen. Air which contain around 21% of oxygen. Fermentation of air, it produces oxygen. So these are the two large scale methods to produce dioxygen. Two methods to produce oxygen in large scale: electrolysis of water, fermentation of air. Okay. One, we have to understand here properties of dioxygen. Properties of oxygen. Oxygen is colorless, odorless gas. Okay. Stable isotope of oxygen is oxygen with atomic mass 16, 17, 18. Stable isotope of oxygen is oxygen 16, 17, 18. Okay. Dioxygen, it is soluble in water. The solubility of oxygen is 3.08 centimeter cube. Solubility of oxygen is 3.08 centimeter cube in 100 centimeter cube of water at 293 Kelvin. At 293 Kelvin, 3.08 centimeter cube of oxygen will dissolve in 100 centimeter cube of water at 293 Kelvin. This is the solubility of oxygen in water. Okay, stable isotope of oxygen is oxygen 16, 17, 18. Dioxygen liquefy at 90 Kelvin. Okay, here dioxygen liquefy at 90 Kelvin and it will freeze at 55 Kelvin. Okay, 55 Kelvin it will freeze and it will change to liquid state at 90 Kelvin. And here we have to understand another points. Oxygen, it will react most of the metals and non-metals. It will react with most of the metals except noble metals such as silver, platinum, gold, etc. Example for such type of chemical reaction, I told you here, oxygen, it will react with most of the metals and non-metals. Example, carbon reacted with oxygen form carbon dioxide. Okay, aluminium reacted with oxygen, it form Al2O3, aluminium oxide. P4, phosphorus reacted with oxygen, it form P2O5. Zinc sulfide, it will react with oxygen, it forms zinc oxide and sulfur dioxide. Okay. So these are some examples for chemical reactions of dioxygen with metals, non-metals, and here zinc oxide, it is one compound. So oxygen, it will react with compounds also. Okay. Here you have some other example. Here some compounds it will catalyze oxidation. Some compounds it will increase the reaction between reaction with oxygen. For example, sulfur dioxide reacted with oxygen, it forms sulfur trioxide. Here V2O5. Vanadium oxide, it will catalyze this chemical reaction. Okay, another one, hydrogen chloride reacted with oxygen, it formed chlorine and water. Hydrogen chloride, it reacted with oxygen, it formed chlorine, Cl2 and water. Copper chloride catalyzes this chemical reaction. Copper chloride. Okay, so here these are some reaction in which compounds catalyze oxidation reaction. Okay, so here we discuss different properties of oxygen. Oxygen, it is colorless, odorless gas, and it will liquefy 90 Kelvin and it will freeze at 55 Kelvin. Solubility of oxygen in water 3.08 in 100 centimeter cube of water at 293 Kelvin. Stable isotopes are oxygen 16, 17, 18. And here oxygen, it will react with most of the metals and non-metals. Example here, carbon reacted with oxygen, carbon dioxide. Aluminium reacted with oxygen, aluminium oxide. Phosphorus reacted with oxygen, P2O5. Zinc sulfide reacted with oxygen, zinc oxide and sulfur dioxide. One more reaction here, CH4. Methane. Organic compounds also react with oxygen, form carbon dioxide and water. Generally, organic compound reacted with oxygen, it form carbon dioxide and water. Okay, and here some compounds catalyze oxidation reaction. Sulfur dioxide, SO2. Sulfur dioxide reacted with oxygen, form sulfur trioxide. Here V2O5. Vanadium pentoxide catalyze this reaction. Hydrogen chloride reacted with oxygen, form chlorine and water. Here copper chloride catalyze this reaction. Clear? Okay, next one, we have to understand here different uses of oxygen. Different uses of oxygen. Mixture of oxygen and acetylene used for welding of metals. Oxygen used in hospital for the patients they have breathing difficulties. Oxygen also used as rocket fuels. These are the uses of oxygen. Some uses of oxygen here. Mixture of acetylene and oxygen used for welding of metals. Oxygen used in hospital for the patients they have breathing difficulties. Also oxygen used as rocket fuels. Okay. Next one, we have to understand here different type of oxide. We can say different type of oxide, simple oxide and mixed oxide. Simple oxide and mixed oxide. Simple oxide, some example for simple oxide, magnesium oxide, aluminium oxide. These are some example for simple oxide. Mixed oxide, some example lead oxide, Pb3O4, Pb3O4. Iron oxide, Fe3O4. These are the example for mixed oxide. Okay, next one, we have to understand here different type of simple oxide. Simple oxide, again we can classify acidic oxide, basic oxide, neutral oxide and amphoteric oxide. Acidic oxide mean their pH less than 7. Basic oxide mean their pH greater than 7. Neutral oxide mean their pH 7. Okay, so look here, acidic oxide. Example for acidic oxide, sulfur dioxide, nitrogen dioxide, carbon dioxide, CO2. These are some example for acidic oxide. Basic oxide. Generally non-metal oxides are acidic. Non-metal oxide, carbon, sulfur, nitrogen, this type of oxides are acidic. Metallic oxides are basic. aluminum oxide, sorry, not aluminum oxide, calcium oxide, sodium oxide, potassium oxide. This type of oxides are basic. Okay, basic oxide mean their pH greater than 7. Next one we have to understand here, neutral oxide. Neutral oxide mean their pH 7, not acidic, not basic. Such type of oxides are neutral oxide. Example, carbon monoxide, dinitrogen pentoxide N2O5, nitrogen monoxide or nitric oxide NO, water H2O. Okay, this type of oxides are neutral oxide. Neutral oxide. Next one, last category, amphoteric oxide. Amphoteric oxide mean oxide they shows both acidic and basic properties. Such type of oxides are called amphoteric oxide. Example for amphoteric oxide, aluminium oxide. Okay, I told you here generally metal oxides are basic. Generally metal oxides. Okay, calcium oxide, sodium oxide, potassium oxide, this type of oxides are basic, but some metal oxides are amphoteric. Example, aluminium oxide, lead oxide, zinc oxide, they are amphoteric in nature. Oxide in amphoteric in nature mean they shows both acidic and basic properties. They shows both acidic and basic properties. Okay. Here you have to understand, here acidic oxide, here acidic substance, it do not react with the acidic substance. There is no reaction. Acidic and acidic substance, no reaction. Similarly, two basic substance also do not react. Basic and basic substance do not react. But we know acidic substance and basic substance, they will react. Okay. Third category, amphoteric. Amphoteric substance, they shows both acidic and basic properties. That's why they will react with the base. Amphoteric substance react with the base. Also, amphoteric substance react with the acid. Clear? Here you have to understand, acidic and acidic substance, no reaction. Basic and basic substance, no reaction. But acid and base, they will react and form salt and water. Similarly, amphoteric substance react with the acid. Amphoteric substance react with the base. I told you here, these are example for amphoteric substance. Aluminium oxide, it is amphoteric substance. See here, aluminium oxide reacted with HCl, it formed aluminium hydrate, aluminium compound, aqueous aluminium compound. Okay, so here aluminium oxide react with HCl. Similarly here aluminium oxide react with sodium hydroxide. So you can see here aluminium oxide, it is amphoteric substance, it will react with the acid, also it will react with the base. So you can identify a substance is amphoteric or not like this way. The given substance reacting with the acid, also it reacting with the base, means it is amphoteric in nature. Clear? Okay, next one we have to understand about ozone. Ozone is one of the allotrope of oxygen. One of the allotrope of oxygen. 3 oxygen atoms join to form O3 molecule, that is ozone. Ozone is highly reactive. It is highly reactive, more reactive than O2. O3 is more reactive than O2. Okay. And here preparation of O3. Oxygen gas after passing through electrical discharge, it will change to ozone. Look here, oxygen after passing through electrical discharge, it will change to O3. Okay, this process is called ozonized. So here we have to understand ozone. Ozone is highly reactive and it is one of the allotrope of oxygen and it produced by ozonized. Clear? We have to understand here some properties of ozone. You can see here ozone, it is in gaseous state, ozone is pale blue color. In gaseous state, ozone is pale blue in color. Similarly, in liquid state, it is dark blue. In solid state, it is violet black. Okay, these are the physical appearance of ozone. Ozone, it is highly reactive than oxygen. We discussed already, ozone is highly reactive than oxygen. Okay, here ozone after decomposition, it produces oxygen and it is exothermic reaction. Delta H minus, it is exothermic reaction. Formation of ozone. Okay, we discussed ozonized. Oxygen after passing through electrical discharge, it will produce ozone, and this process is endothermic process. It absorbs heat energy, endothermic. But decomposition of ozone to oxygen, it is exothermic process. Clear? Also, ozone, it is powerful oxidizing agent. Ozone is powerful oxidizing agent. Nitric oxide, nitrogen oxide or nitric oxide, NO, it deplete, it break ozone layer. Okay, it cause ozone layer depletion. Which oxide? Nitrogen monoxide. So these are the different properties of ozone. Okay, here physical appearance of ozone. In gaseous state, it is pale blue. In liquid state, it is dark blue. Solid state, it is violet black. Okay, decomposition of ozone to oxygen, it is exothermic reaction. Formation of ozone, converting oxygen to ozone, it is endothermic process. Okay, here ozone, it is powerful oxidizing agent. Oxides of nitrogen monoxide, it will deplete ozone layer, it break ozone layer. Clear? These are the different properties of ozone. Here you can see the resonance structure of ozone. This is the resonance structure of ozone. Okay. Also there are some uses for ozone. Ozone used as germicide. Ozone used as germicide. Also it used as disinfectant. Ozone used as disinfectant. Also ozone helps to bleach oil, starch, similarly flour. Okay. Here ozone helps to bleach oil, flour and starch. Clear? Also here ozone used as oxidizing agent in the manufacturing of KMnO4. In the manufacturing of potassium permanganate, we can use ozone. Clear? So these are the things we have to discuss in this video. You can just review this video once again. Okay. So thank you for watching this channel.